Welcome, this is Joshua Myers, and this is my Project 10 demo. Here's my setup. So what I have here in the upper right-hand corner is a host build environment. It's actually a virtual machine running on my MacBook. I'm most comfortable in Linux. I could have easily set up the host build environment on my MacBook, but I like developing in Linux. I'm more comfortable there. So I have a VM where I am developing all my code and compiling it with a cross compiler, and then SCPing the executable over to the Raspberry Pi. In the lower right-hand corner is a diagram of my system. I have the IONU slaved to the Arduino over I2C. The Arduino is slaved to the Raspberry Pi over I2C, and the Raspberry Pi is transmitting the GPS and IMU data over UDP packets, and also transmitting the real-time video over HTTP. The Arduino has two tasks running. One continuously gets IMU data from the IMU and stores it in a shared structure. The other task waits for the Raspberry Pi to request data and then locks that shared data structure, copies data out of it, and sends it to the Raspberry Pi. The Raspberry Pi has an executable running. The executable has two threads. One thread periodically gets IMU data from the Arduino. The other thread is sort of driven by the GPS device. It reads whatever data is available on the serial port, and then each one of those threads broadcasts the data out over a UDP socket. It's the same UDP socket, so there's a mutex that protects the socket, so that one thread can send its data and the other thread can send its data without them interfering with each other. Then going clockwise, on the lower left of the screen there is the video of my quadcopter, and then on the upper left is the real-time video coming from the web camera attached to the Raspberry Pi. Okay, so back to my host build environment in the upper right-hand corner there. I'm going to open up Eclipse. Here's my main executable that runs on the Raspberry Pi. It has two threads, one that reads from the serial, and then the main thread reads from I2C. Each have a mutex there to protect the UDP socket. This is my I2C module that reads the IMU data from the Arduino. The serial port reader that reads GPS data from the GPS device. And then finally, I have the UDP module that sends UDP data from the Raspberry Pi out to whoever would like to listen to it. So once the target is built, I will SCP it over to the Raspberry Pi and find the right terminal. So here we go. So once it's built, I SCP it over to the Raspberry Pi. I could easily set Eclipse up to do that work for me, but I didn't take the time. I manually copied that one executable over to the Raspberry Pi. So that executable is running on the Raspberry Pi currently. And what I'm doing here is just using Netcat to listen to the UDP packets that are being broadcast. And here I have an SSH session running that's printing out the debug information from the Raspberry Pi program. And as you can see in I2C here, so let me jump over to the Raspberry Pi and see if I can restart that Arduino process and get the I2C data going again. What's not shown in my diagram there on the bottom is I still have the USB serial port connected from the Arduino to the Raspberry Pi for debug purposes. So I'm going to log into the serial port, and there we go. It kicked off the Arduino program again, and the I2C errors went away. Now you can see there's IMU data coming from the Arduino to the Raspberry Pi. The GPS data and the IMU data are interleaved here. What you'll see is the GPS data all starts with the $sign. That's just the raw data coming from the GPS device. And messages coming from the Arduino to the Raspberry Pi with the IMU data, just have a count in the beginning. So I'm just counting the number of packets that I've received from the Arduino to the Raspberry Pi and then broadcast over UDP. They're interleaved because I wanted to show that the socket was being shared between the two threads there and not interfering with each other. So now what I'm going to do is get up and walk around with the quadcopter. I'm just going to grab it and manually change the pitch and roll, take it outside, walk around with it, show the GPS data is updating and the IMU data is updating in real time, being broadcast over the UDP to my host. And also the video is working in real time. It's being streamed over HTTP. I'm viewing that on my host. So here I come in the window here. So that was my daughter, my wife, my granddaughter. Here I come in the window. Just going to walk around with it a while and show that it's all still working in real time. I have not gotten the quadcopter to fly yet. So when this portion of the video is finished and I can prove it's all working in real time, I will go back to attempting to get the quadcopter to fly one last time. And it looks like one of the cables got in front of the webcam there. I'll have to fix that before I attempt to fly it. So now that I've walked around with it a little bit, I'm going to come back inside and set it back on the table here. And then I'm going to attempt to fly it one last time. So here's one final flight attempt. Took everything off the quadcopter, checked all the wiring, made sure all the motors were turning in the right direction. I recalibrated it. Unfortunately, every time I try to fly, the quadcopter flips over on the side immediately. And that concludes this demo, as well as my work in this class. It's been a very good class. The instructor was very helpful, so thank you. Very educational, very well put together class. This has been a really good one. It was fun, despite not getting the quadcopter to fly. So again, thank you, and that concludes my demo.